Hello viewers, welcome to a new video tutorial in JS and RS Solution channel. In this tutorial, I will show you an open source software of US EPA named ALOHA, that means Areal Locations of Hazardous Atmospheres, which you can use for risk assessment and simulation. This is a modeling program that estimates threat zones associated with hazardous chemical releases, including toxic gas clouds, fires, and explosions. I will show you A to Z of this software from downloading, installing, and exercise with an example. You can represent ALOHA output using ArcMap. Now I will show you some published journal articles where authors have been used this software for simulation of hazard consequences and many more. Hazard evaluation using ALOHA tool in storage area of an oil refinery. Then software systems for prediction and immediate assessment of emergency situations on municipalities' territories. Quantitative risk assessment in LPG storage area for different fire scenarios. Risk quantitative calculation and ALOHA simulation on the leakage accident of a natural gas power plant. Also, you can perform this type of analysis, hazard footprint for chlorine and for different chemicals, scenario 2 and many more. Consequence evaluation of toxic chemicals release. Assessment of accidental release of ethanol and its dangerous consequences using ALOHA. Human risk assessment of single exposure in chemical incidents. Hazard evaluation using ALOHA tool in storage area of an oil refinery. You can perform this type of analysis using this software and write articles and publish your paper. First, we will download the ALOHA software. Write ALOHA software. Then click ALOHA software US EPA. You will get this interface: United States Environmental Protection Agency. ALOHA software. Downloading ALOHA. Here you can see two options: download ALOHA for Windows, download ALOHA for Mac. So I will download ALOHA for Windows. Here is the downloaded software. I will install now. Run as administrator. Then click next. Accept the agreement. Next. You can create a desktop shortcut. Next. Install. ALOHA version 5.4.7 has installations completed. Now I will open ALOHA software. Click OK. You can also download ALOHA examples. You will find here some examples how you can run ALOHA for different scenarios. Anyway, here is some tools of ALOHA. You can see here. We need some data to run this software, like your locations, building, time, chemical data, and atmospheric data. First, I will set up location. You will find here some locations of USA. To add your locations, to add your industry location, click on modify, write the name of your location. I'm writing my study location where my industry is located. Is location in US state or territory? If it is, then select in US, or if your location is outside of US, then select not in US. Enter approximate elevation. I'm giving 19 as the elevation, 19 meter for my area. Enter approximate location. As this is my industry location, this is the point. I need lat and long, as here required degree and minute. So I need to change the degree minute second to degree and minute. Go to options in Google Earth, then click degree decimal minute, then OK. Now I will take latitude and longitude. I'm going to write here latitude and longitude. Latitude and longitude, north and east direction, then click OK. You can see here help option. uh, then country name, and offset from local standard time to GMT. For my location it will be minus 6 hours. Eastern hemisphere is a negative offset. And then is current model time standard or daylight savings time. So for my case standard time, then click OK. You can see here Mongla Bangladesh has been set here, then click select. You can see over here my location has been added here, Mongla Bangladesh. And then site data, building type, select building type or enter exchange parameter. You can see here some options. I'm selecting single story building, and select building surroundings. Here you can see two options, sheltered surroundings and unsheltered surroundings. So sheltered surroundings buildings, that means sheltered buildings are surrounded by large obstacles such as other buildings, trees, or bushes that might obstruct the wind flow. And unsheltered buildings are in an open space that is not surrounded by any large obstacles, and the wind blows directly into the buildings. And then date and time options. You can either use the computer's internal clock for the model's date and time, or set a constant date and time. Use your computer's internal clock. This is Aloha's default choice. It is already selected when you start Aloha, so you don't need to set the date and time if you want to use the computer's clock. This is the right choice if you are modeling an incident that is occurring right now. And set a constant time of your choosing. This option is useful if you are using Aloha for contingency planning or training exercises, because you can set up scenarios to run at different times of the day and or year. I'm selecting use internal clock as I'm going to simulate the risk. Choose the chemical list that is being released. You can see here pure chemicals. You will find here some chemicals from the list. If you need to add more chemicals, then you can use modify tools to add more chemicals that is being used in your facility. Also, you can see here solutions. You can add solutions from this list. In my facility, they're using chlorine, so I have selected chlorine. You can see here chemical data as chlorine has been added here. You can see molecular weight, then ambient boiling point, freezing point are added here. Now I will add atmospheric data, user input. First I will add wind speed. The wind speed is 8 mile per hour, or you can use meter per second. Then wind is from which direction? Northeastern. Enter degrees, true or text. Then measurement height above ground is, you can see here two options. The SAM stations icon on the left is equivalent to entering a measurement height of 3 meters, because most SAM stations are mounted on a 3-meter stand. And the tower icon is equivalent to entering a measurement height of 10 meters, about 33 feet, because that is the height at which the National Weather Service usually reports wind speed. Then ground roughness is, you can see here three options: open country, urban or forest, or open water. So in my facility area, it is open country. So I have selected open country here as ground roughness, and then select cloud cover. So I have selected partly cloudy, then click OK. Atmospheric option 2, air temperature is 33. Aloha needs a value for the air temperature in the vicinity of the chemical release, because it influences Aloha's estimate of the evaporation rate from a puddle surface. The higher the air temperature, the more the puddle is warmed by the air above it, and the higher the liquid's vapor pressure is, the faster the substance evaporates. Because several physical processes involved in a chemical release are affected by temperature, use as accurate as value as possible. Aloha uses the stability class table automatically. Choose the stability class that best represents the conditions that you entered for time of day, date, wind speed, and cloud cover. If you want to know more about each function, just click on the help option in toolbar. You will get every details of it. Inversion height. An inversion is an atmospheric condition in which an unstable layer of air near the ground lies beneath a very stable layer of air above. The height of the abrupt change of atmospheric stability is called the inversion height, An inversion can trap pollutant gases below the inversion height, causing ground level concentrations to reach higher levels than would otherwise be expected. Humidity, as you already know, relative humidity is the ratio of the amount of water vapor that the air contains to the maximum amount of water vapor that the air could hold at the ambient temperature and pressure. And ALOHA uses this relative humidity value to estimate the value of atmospheric transmissivity, estimate the rate of evaporation, make heavy gas dispersion computations. Then click OK. After that, you will see here atmospheric data has been added. Wind, cloud cover, stability class, relative humidity, air temperature, ground roughness. Then setting the source. Here you can see four sources. Direct source, that means chemical release directly into the atmosphere. And then puddle, that means chemical has formed a liquid pool. And tank, it refers chemical is escaping from a storage tank. And then gas pipeline, it means chemical is escaping from a ruptured gas pipeline. Here in my case, as I am working here for a chlorine tank, therefore I have selected tank as source. Tank size and orientation. Select tank type and orientation. I'm selecting horizontal cylinder and then enter two of three values: diameter, length, and volume, and then click OK. Chemical state and temperature. You can see here enter state of the chemical. Tank contains liquid or gas or unknown. I'm selecting liquid. Enter the temperature within the tank. So, then click OK. Liquid mass or volume. Enter the mass in the tank or volume of the liquid. Then click OK. Then area and type of leak. Select the shape that best represents the shape of the opening through which the pollutant is exiting. For my facility, it is circular opening, then opening diameter 0.05. You will put for the measurement for your facility. Then is leak through a hole or a short pipe valve. So in my case, short pipe or valve. Then click OK, and then the bottom of the leak is 1.25 feet, and then click OK. And you will see here source strength has been added here. You will find some lots of information that you have entered, and then go to setup and calculation option. Select the spreading algorithm for downward dispersion. Check let ALOHA decide, then click OK, and then go to display and display option. Select output units. I'm selecting English units, and then display threat zone. A threat zone is the area within which ALOHA predicts the hazard level to exceed your level of concern, that means LOC, at some time after a release begins. ALOHA can model multiple hazards like toxicity, flammability, thermal radiation, or overpressure, and the type of LOC that you choose will vary based on the hazard. For each scenario, you may specify up to 3 LOC in ALOHA. If 3 LOC are chosen, ALOHA will display the threat zones in red, orange, and yellow overlaid on a single picture. By default, the red zone represents the worst hazard. After that, click OK. You can see over here predicted pollutant concentration, I mean toxic threat zone estimation for chlorine. The red line means high hazard consequences threat zone. From the text summary, you will get some information based on your data that you entered into Aloha, like information that you entered about the release sources, in this case a tank. This section also includes details about Aloha's source strength calculation, such as release duration, amount released, and release rate. Also, you will get information about the threat zone estimate based on the scenario details that you entered. Also, information about the threat, in this case, toxic gas concentration at a location that you selected. You can use the threat at point option to obtain specific information about the hazard at a point of interest, such as a school or a hospital in or around the threat zones. Specify the location at which you want to evaluate the concentration over time. You can see here two options: relative coordinates and fixed coordinates. So relative coordinates, I mean downwind and crosswind. Choose this option when you wish to know the hazard expected at a position that can best be described in terms of its downwind and crosswind distance from the release point. And using fixed coordinates, east, west, and north, south, choose this option if you wish to know the hazard expected at a specific geographical locations. I have selected here relative coordinates, and input x the downwind distance from the source, and y the perpendicular distance from the downwind axis. When you use relative coordinates, Aloha will remember the location of the point that you have specified in terms of its downwind and crosswind distance to the source. Therefore, the geographic location of the point that you have specified to Aloha will move when the wind direction changes. Input x, the downwind distance, I'm writing here 1500, and input y, the crosswind distance, I'm writing 0. Then click OK. You will get this concentration at point graph. The concentration at point graph displays ground level chemical concentrations in indoor and outdoor air at the specified location during the first hour after the beginning of a chemical release. You can see here overall analysis, I mean analyzed data here. Now I will show you how you will save this data for this export thread zones. Then you will see two file format. First file you can save for ArcMap, and then second on CAMEO for mapping programs such as Google Earth. I will save as CAMEO format, and then we'll export in ArcMap. So you need to add here latitude and longitude. I will put latitude and longitude from my location. First, I will set degree, minute, second. I'm writing latitude, degree, minute, and seconds. and then longitude, and then click OK. Create a folder where you want to save your file. So here is my file as CAMEO format. You can see here my facility area. ALOHA source point and ALOHA thread point. If you click here, then you can see thread zone. I mean time, chemical name, wind speed, thread zone details, rate 1055 years in red zone, orange and yellow. It details about hazard consequences. You can show the output in ArcGIS as well what in Marplot software. Here is my CAMEO file that I have saved. First, I will convert CAMEO to layer, input CAMEO file, and then click OK. I'm going to rename it as thread zone. You can change the symbol. So first, I will export data. Export data. Categories, then go to attribute, is name, ALOHA source point and ALOHA thread point. Go to properties and then symbology, categories, uncheck these on, and then select name, add all values. Rename it thread zone. And then go to properties. Before that, check the level, name, properties, and then symbology, then categories. Uncheck these on, and then select name, and then add all values. This is a level of concern, I mean LOC. I think you know how to make a map layout. So you can show the Aloha hazard consequences results using ArcMap. Anyway, I hope you have enjoyed today's tutorial and this will be very helpful for you. Thank you for being with us, and if you find this GIS and RS Solution YouTube channel interesting and helpful, Please subscribe.